AI Game Changers podcast with Luke Whips.
So do you want to kind of kick off and just take us like right back to the beginning? So how did your kind of professional career start? Where did you study? What did you study? Like, how did your step into the professional world, either from an academic perspective or from a professional standpoint, how did everything start for you?
Yeah, so I have a pretty broad background with technology in general, and it basically already started when I was quite young, when my dad showed me how to take apart old electronic devices, fix a radio, and look inside. And for me, it was just, wow, there's lots of little funny looking things inside there, lots of different components. And at that time, I actually had no idea how all that works, but it really sparked my curiosity to understand what is actually the driving force behind technology and how that works. And with I think the age of 16, I had my first job where I was building computers for industrial use. So like just assembling hundreds of computers, putting in all the components. And from there, I switched over to more the design area of the computers to design the schematics, the electric boards themselves. And something that really struck me that day, it was that when we were redesigning some old products that they have developed 20 years ago, we could basically get rid of about 80% of the parts by just introducing a faster and better chip and moving all the logic and the complexity into software. And this really baffled me that time, that like, wow, software is actually right now the driving force behind most of the things, and the electronics themselves mainly serve some basic use, that they make the product work in all different kinds of conditions and make it that it runs stably. But the whole logic and the complexity is actually done in the software.
Mm. Yeah. So, I mean, I've seen people transition from electrical engineering to software quite often, and I didn't ever really understand how that transition was possible because I thought they were two completely different fields, right? But from what I've seen, people that start in that electrical engineering kind of foundation and then transition into ML or software, they've got that slightly deeper understanding of how things actually work from a lower level perspective in that lower level application. So when they go to software, you can kind of join the dots between the two, right? And think, oh, actually, this is how these two things combined, right? So do you feel like that gave you quite a good, like studying electrical engineering in the first piece, did you feel like that gave you quite a good foundation to be able to work from, and a slightly different angle from what people who just study normal kind of computer science, do you feel like you had a different view on how things should be done based on that?
Yeah, I think it's definitely very important to, if you want to build a great product, and if you want to make innovation with technology, you really have to understand the whole pipeline and the whole process of developing this product and how it all comes together. So I think having some understanding of the underlying principles and the underlying technology that's driving the product is actually quite beneficial. So I personally, I didn't study electrical engineering. I did some work in that area when I was designing these electric boards. But for me, the missing dot between actually just the pure electronics and the software was actually the chips that run the software. So this was the main reason why I moved to Munich to study physics, with a pretty strong focus at the beginning on semiconductor physics and nanotechnology, because I really wanted to understand how do actually these logical operations work on first principles, on the physical level, that the software is built on top of. And I think actually having this kind of background knowledge really helps you think about the applications, what you can do with it. I don't have a strong background in like embedded programming and really programming the chips themselves, but I think just understanding how chips work on like the principles And what you can do with software really helps you to connect these dots and really think about the product as a whole.
So what happened then? So after your academic studies, so I mean, up until now, you've done quite a lot, right, comparatively to what most people would have done by this stage. So, I mean, what happened after that, and how was your transition into data science and ML? Because you've touched on so many different points, right? So, after your academic studies, what happened then?
So basically, already during my studies, I was always working on the side. At the beginning, my first touch points with software were mostly like classical software engineering, doing front end and back end work. And with my study focus then shifted a bit from the pure semiconductor physics to actually applications where you use data and where you want to use data to derive knowledge. And for me, one of the areas that really directly called my attention was actually astronomy, because astronomy has this huge history of data collection and doing observations for decades basically. And so they had a very strong foundation in statistics, in also machine learning in the newer topics. So I started a research assistant position at a Max Planck Institute for Extraterrestrial Physics, and did work there for about 3 years doing research in gamma ray astronomy. So basically high energy photons coming from very distant locations in the universe. And for me, it was quite interesting to see, like, okay, we have these detectors that are somewhere on a satellite producing a big stream of data. So we have like gigabytes and terabytes of data, and we can actually use that to derive knowledge of what is actually behind that. Like that there's, for example, some kind of star that is exploding and sending us a pretty strong signal, and we can actually just write code and fit some physical model to the data we're observing. And we can actually then see, okay, this is this type of source, and we can really derive understanding of our surrounding by using software. And what I realized there is that you can do a lot of things with pure statistics and building physical models and putting in your knowledge from science. But there's also applications where they're actually so complex to describe that it's really hard to derive some physical model from first principles. And this is really where machine learning shines, where we can really build applications, build models that can serve a purpose that you couldn't do by just writing down a classical statistical model. And yeah, this was really where I saw, like, okay, machine learning is quite interesting. It's a bit different than normal statistics or classical statistics, but it uses the same techniques, the same principles, also some of the same software that you can use. But you focus a lot more on using data and creating some predictions or some recommendations out of your data that you can apply in your daily use. For example, to have impact here down on Earth, and not just looking into space and observing the universe. But here it's actually the impact is what's important. You really want to build something that's impacting some people, or impacting nature, or climate change, or something that you're really passionate about. And sometimes it's not just about understanding the causes of things and understanding like the scientific part, but sometimes you also really want to take action. And this really made me think, okay, I really want to apply all this knowledge and these technologies to build something that's tangible, that we can use, and that really can change lives of people.
Well, do you know what, Felix? That was going to be my follow-up question. Like, why did you transition out of that research kind of area? Because, I mean, what you're talking about now is obviously super, super interesting, right? And, I mean, we could do a whole other podcast on that piece on its own, right? But, I mean, transitioning from that to then becoming a co-founder and a CTO of a business is a huge, like, they're on opposite poles, right? So, I mean, what was it that you weren't necessarily getting from you say it was more of the tangible impact seeing the results of your work actually affect other people and what you care about, right?
Yeah, for sure. So I think when you're doing research in science, you're really advancing the pure knowledge we have, let's say, as humanity. But sometimes this knowledge is quite detached from the actual problems we have these days. And for me, something that for me personally was missing is I'm investing so much work, so much effort in something, but I also want to see some change by putting in all this work. I want to see some impact coming out of that. And for me, like there was this made me think, does it make sense right now to pursue a PhD in the more scientific work and find a topic where you can have impact, but doing it purely from a research perspective? But then I thought, okay, there should be other options. There should be other ways to actually directly apply it, like build something that's still quite research and scientific driven, but that directly has some impact. And this is basically when I got to know my co-founders, and we really we found a very nice topic where you can actually be connected quite strongly with pure scientific research, but still do something very innovative that directly has impact on the lives of people. So this really really motivated me to go more into this topics.
And I guess the question there then is like, how did you know that was the right decision? Because there's people, I mean, I don't want to polarize people too much or oversimplify it, but usually what I see is people have there are two types of people within kind of like ML and data science, right? There are the research academic, they're all about, as you say, just, advancement of the knowledge base that we have within a particular thing, but they typically don't really not care, but they're not driven to actually build anything, right? From a product standpoint, it's very much on that academic side of things. And then you get other people like yourself who they've just got some kind of feeling where they're like, I just want to make something happen and I want to see real world tangible results, right? So like, how did you know that was the right decision? Was it a gut feeling, or was there any kind of, I mean, I know data scientists don't typically work with gut feelings, right? But what was how did you even process that internally?
Yeah, I think it's definitely some part of it is definitely gut feeling, and I think from a pure innovation point of view, both sides of the coin are quite important. You need the scientific research that actually derive the new technologies, or like do the scientific part, and then you also need the application of it. So I think it's not one over the other. I think both parts are very important, and I guess, as you said, it probably depends a bit also on the personality of the person. I guess being a founder or trying to build a product, it might not be for everyone, but it's definitely a lot of fun to do when you can really invest into something and you have your basically like a baby that you nurture and it grows and you can see some achievements with it, and you can also see that actually you have some impact with it. So you can, you're not just advancing science and writing some papers that might get read or might not, but you can really have something that's usable, that's tangible. Yeah, I think it's mostly gut feeling. Like you feel like this is what I should do.
So let's talk about, so after your research days, so obviously you were doing some kind of like full stack development and engineering alongside all of your research and stuff, right? But in 2018, you founded Res Mechanica, right? And that was your first kind of step into the real kind of production world, I guess. I know you've done some stuff previously, but like that for me would be your real, okay, right, we're doing this. This is the business and this is kind of the plan. So take me back to that first day of starting. Oh, actually, no, let me reframe this. So take me back to the moment that you decided that you wanted to do that, meeting the co-founders, meeting the people that you were going to set up with. What happened? Give me the picture.
Yeah, so with Res Mechanica, we started quite broad, and at the beginning we basically had two products that we built, two different applications of ML in the industry, and one of it was Hema.to, where we wanted to bring impact to the diagnostics in hematology and especially in leukemia. And the other one was quite different, doing personalization and optimization in CRM, so customer relation management and optimizing these customer journeys. And from us at the beginning, it was mostly about applications of technology and finding a good use case where you can use these types of new tech, and building something that's technically challenging. I think this was something that motivated me quite a lot at the beginning. So as I said, we started basically with Hema.to and built a first proof of concept. So actually the story behind it is quite interesting, because one of the old colleagues of my two co-founders that they studied with, he's now head of one of the research institutes at the University of Bonn. And in his working group, there was a proof of concept by a PhD student that leukemia can actually be diagnosed on a level of a human by using AI. And as a good friend of my co-founders, he asked if we actually want to use this product, or if this concept, and really build a product around it. And so we built a web application at the beginning around it, where a laboratory can actually use it, and quickly developed our own algorithms, which actually were even superior and could diagnose leukemia like better than a human expert. And but sadly, at this point, the laboratory actually wanted to have the service exclusively for them. But this is not really how you can build a company. You need a big customer base, but also we really wanted to use this technology to bring impact, not just to one little local area, but actually to roll it out on a bigger, maybe even global scale, because this is something like leukemia and cancer is not something that's just happening here. It's a global problem. And this is why we said, like, okay, now we really want to build a big product around that. We want to use this to provide change, to bring impact to many people. And this is why we separated ways. And for some time, we mostly focused on the other project in CRM, because we had some customers there. We could pay our bills basically. But it was quite interesting from a technology perspective. So doing diagnostics in leukemia is mostly like supervised deep learning. And for the other area, we used reinforcement learning. So it's quite two different approaches of ML, and they have their own challenges of the infrastructure and all the pipelines you have to build around it. So from a CTO perspective, there's a lot of things you can learn, or a lot of things you have to build. But yeah, just basically.
Yeah. I guess honestly speaking, I think the one thing that I know about data scientists and machine learning engineers and people that work in our industry, the one thing that I would say that pretty much everyone shares is that they want to work on things with tangible impact, right? And I think if anyone comes to you and says, hey, we've got loads of research based on leukemia diagnostics, do you want to build some models around that? I'm pretty sure most people would say yes, right? And to be honest with you, Felix, like before I invited you guys onto the podcast, cancer, as awful as it is, has touched probably everyone either directly or indirectly at some stage in their life, right? And when I saw what you guys are working on, for me, it's just a story that I wanted to share, because ultimately, if there are people listening to this and you guys can get highlighted within the community, in the AI community, and people can help you, and people want to get on board and join you guys and help from a research standpoint, that's a story I want to share, right? So I'm sure that we probably share the same mindset about the potential impact of what you guys are working on. And it's amazing, man. I mean, like, you know, for me, I think this is one of the reasons actually that I got into, that I realized why I love recruiting into artificial intelligence is because the impact that you can have is just astronomical, right? And although other technical areas are cool, like security is great, and you know, cloud and all of that sort of stuff is really cool, but I don't know, it's like it's a lot more tangible and a lot more like you can taste it a lot more in artificial intelligence, right? Like you can really see the benefits to human beings and the planet and, you know, other really cool use cases. So I mean, I think what you guys are working on is absolutely incredible. So how has it been so far? Like, if you look back and think about the first day compared to now, do you feel like you went into the problem solving development problem in general with any naivety or any ignorance, or just run me through it? Like, how does it feel from your side looking back now?
Yeah, so basically, when you start building a product like this, what I think you should do is you should build something very small, but that already have some impact, that already can, where you can test your hypothesis if this product can work. In our case, it was basically a machine learning model that can just say it's this type of disease or this type of disease. So we just built a very simple web application where you can upload data and see the results. But of course, if you want to build something that's getting used in a clinical context, there's a lot of other challenges and a lot of other things you have to actually consider. So I definitely think at the beginning, like you should start very small, but also when you just think about this small use case or this small proof of concept, there's definitely a lot of things that we didn't consider at the beginning, or that we thought might be easier. And especially, I guess, building a medical product and the whole building something that's actually compliant as a medical product introduces a lot of new challenges. So we like coming from this first proof of concept and just building something that's can be used for research purpose. We now transitioned over to a product that can actually be used in a daily clinical use and is certified. So starting this year, we basically in a very short period of time, we rewrote the entire application and the entire product to make it and started fresh with a quality management system. So we can actually have everything documented, have reasoning of every little component in the code. We can demonstrate like which line of code, where did it come from, how is it justified that we actually need this there, and have everything fully tested with the typical unit tests, integration tests, like all that kind of things. And but this is all just the technology. But what really shines, or what really where you can really get engaged with the product, is when you actually see it being used by customers. And this year in April, we had our latest clinical studies where the product was used at 4 different study sites, and there the doctors basically used they diagnosed some patients with their typical workflow and some with the use of Hema.to. And actually seeing this direct comparison, how do they use our product, how do they use the typical approach, this is when it gets really interesting, and when you can really see, okay, that AI actually is ready to bring change, it's ready to automate processes, but it's also ready to improve. And this is something for me that's really amazing, that it's not just some recommendation system that it's right in, let's say, 60% or 70% of the cases, which is enough if you want to just sell something. But if you want to have a diagnosis, this has to be at least on the level of a human, but it should be above. And actually demonstrating this in the studies, that we can actually improve the diagnoses, not just making the whole process more efficient and saving time and all that, but really on the key performance of the accuracy of the diagnosis improving there. This for me was amazing. Just really seeing that actually the tool can help the doctors to improve the lives of the patients, basically.
Yeah, honestly, dude, I've got so many questions. I don't know where to start, but I guess the one thing that's like jumping out to me is like, how does it make you feel when you realize that the things that you're building could potentially save lives in a much more accurate and higher performance way than what a human could be? Like, how does that feel as a human being?
Yeah, it definitely feels quite good. It's really motivating to even put in more effort, and it's also for me, it's not just how it makes you feel personally, but also how you can motivate other people, how you can get other people engaged, how you can find good talent that helps you work building these products, because this is not something that you can do by yourself. This is something quite complex that is also not just engineering. You also need compliance, you need legal aspects. Also from the tech perspective, there's front end, back end, machine learning, cloud infrastructure. There's so many components and bits and pieces that are working in there. But really seeing a smile on people's faces when you tell them the story, or when you show them the results, or from the users that they're really amazed of how well it already works. And this is just like the first iteration. This definitely is quite nice.
I bet, man. Because, there are so many different use cases out there for ML and data science and, all of the buzzwords. Like you mentioned earlier, right? You could build a recommendation system right? I just want to add a caveat here. Nothing is, I'm not saying that any of this is bad or like not worthy, but comparatively, in terms of that emotional connection towards what you're building, you could go and build a recommendation system for Spotify, which, is cool. Like, I use it every day, right? And, it feeds me new music. And sometimes I find really good artists. And you could probably argue that you have impact in people's lives, which you do. But to increase the performance of like early diagnostics for like leukemia, which could potentially save someone's life, I mean, that for me is a whole different ball game, right? And I don't think you can compare those two use cases in the same category in terms of like emotional connection and stuff, right? So I'm with you 100%. I totally understand. Well, I could empathize about how I think you would feel, but I mean, if you're at the head of a company and you're actually building that and you could see that impact, I could never imagine how proud you must be of the work you're doing, right? So it's really amazing, man. So if anyone's listening right now and they want to reach out to the guys, because I think they're hiring, please do. But anyway, so can you just to kind of bring it back a little bit, I guess. So correct me if I'm wrong here. So you can diagnose leukemia in two ways. Is that correct? Through blood and bone marrow?
Yes, correct.
Is that correct?
So there's different diagnostic methods that are used. One of the main methods that are used is called flow cytometry. And this is basically a method for immunophenotyping. So you're basically analyzing how your immune system responds to some kind of disease, for example, leukemia. And the pure material that is analyzed in flow cytometry is either bone marrow or peripheral blood.
Right. Okay. And in both of those situations, if you're analyzing bone marrow and blood, you're looking for, or is it two separate analysis for those two things, or are you looking for a particular thing that spreads across both of those two things?
It depends a bit on what kind of disease the patient has. So for some types of leukemia or B lymphocytes, it's helpful to analyze bone marrow, and for others, peripheral blood is also sufficient. Of course, a bone marrow puncture is a lot less comfortable for the patient. So if it's not necessary, they don't do it always. But like flow cytometry, what you actually do is you take these type of blood samples and you mix it with some cocktail of biomarkers that bind to the surface of these blood cells. Then they shoot with a strong light on it, with a laser, and measure the fluorescence of these cells. So a cell that lights up, let's say, strongly in blue has a lot of these blue biomarkers bound to the surface. And these biomarkers could be expressive for some type of disease or to separate different types of cells.
Right. Okay. Gotcha. And so visually, then, how does it work? Like, say, if I'm a clinician, how would we use the Hema.to platform? Is it based on real, like live data from a camera, or is it based on like captured image data? Like, how do you work with the data sources from a clinical perspective?
So the data that comes out of these machines, of these flow cytometers, is actually high dimensional. So what they do is they measure, let's say, 100,000 cells for one patient, and they use 10 different colors. So they have, for these 100,000 cells, they have 10 different measurements, 10 different values. But the clinician can't look at 10 dimensions at the same time. So for a human, this is like, we can't visualize that very well. So what they right now do is they look at 2D scatter plots. So they project the data on just 2 dimensions and then compare about 15 to 20 of these plots. And then they use a manual process, which is called gating, where they basically separate these different types of populations manually by drawing a line or circling around these populations to select out the population that they're interested in that could be expressive for some type of disease. So the whole data processing is quite complex, and this is really completely done manually right now. And with Hema.to, we basically make this whole process completely obsolete. So we can directly use the raw data that comes out of these flow cytometers and directly derive a diagnosis. And we then use some types of gating to visualize the data in a way that the doctor can comprehend it better, and to indicate him, okay, look here, there's this type of cell population that's abnormal, that could be expressive for this type of disease. But the workflow is basically, we get the raw data in and directly derive a recommendation for a diagnosis, because we're not directly diagnosing it. We're helping the doctor to come to a conclusion, but we give him a recommendation and really putting certainty, like a confidence on that. So we're doing, we can really say we are 98% confident that this patient has disease A or disease B.
Mm-mm. And what is I don't know if you've got this statistic to hand, but what is the percentage of correct diagnostics from clinicians right now? Like, how many do they correctly diagnose per year? How many do they miss? Like, do you have any percentage or statistics around that?
So this is a number that is quite hard to find, to really know what's the level of the humans right now. But some numbers that we found right now is that it's between 2 and 5% of misdiagnoses by just using this technique. So there's other types of diagnostic methods that can be combined with flow cytometry, and with just pure flow cytometry, the separation between two diseases sometimes is not completely clear. But if you take, for example, a morphology, where you basically look at the cells under a microscope, then you can really distinguish between two different classes. And so by doing this follow-up analysis, they can see like what would have been the correct diagnosis and what the doctor actually gave. And from these numbers, it's about 5%, with just like the first step with using flow cytometry. But this we can already decrease greatly. So we can already see an impact there that with just using flow cytometry and AI, we can already derive better diagnoses.
So I guess the ultimate goal then is to, well, actually, sorry, I probably should ask this question rather than just assume, but so with Hema.to then, because you mentioned you're on the first iteration right now, right? So this is kind of starting block one, right? What's the next iterations in terms of the diagnostics and the the application layers that you would work on? Or are you looking to build like a full end-to-end diagnostics platform that can visualize and analyze different data sets across pretty much everything? Or what's the end goal, I guess?
So the main goal of the company is to work across the whole immunophenotyping landscape, and not just doing diagnostics, but also really using this technology to have an impact also on therapy. Because right now, what like one part is just to know which disease you have, but then you actually also want to treat that, and to, for example, predict the outcome of the treatment, or to monitor how well the treatment works. This is also things that you can do with flow cytometry, and we can really use our expertise here to not only do the first step of the diagnosis, but the full path from knowing, okay, something is wrong with that patient, to diagnosing, to treating this patient, and then also monitoring him afterwards so he doesn't get a relapse. So like the whole
Wow.
life cycle of the patient, of becoming sick and getting treated and being healthy again, and also monitoring afterwards. This is something we want to optimize as a whole. So that this whole sequence of events. And I think our like the initial step here is the diagnostics, where we already like where it's we have the expertise already. We have a lot of data for that to train the models and to build a product. But this for us is just like the first initial step, and from where we want to expand.
That is fascinating, man. So, do you know what? I wish we had loads more time, because I would love to kind of talk about those other steps. And I know they're probably not set out and super clear right now, but I would imagine out of that workflow, the therapy recommendations would probably be the most difficult to get right, because um, my mind's gone blank now. The third thing that you said, what was it? It was after the diagnostics, you would do
The
the therapy
monitoring for
recommendations and then
relapse.
monitoring. Yeah, so that I would imagine would be probably a more simplistic thing than actually recommending what therapy based on what type of disease is presented, right? Is that correct? Or
I think with the applications of AI, it always comes down to the data you have and the knowledge you can derive from there. And if you have the data to support your use case, then and it's solvable by, let's say, by a human, or a human can have good indication of what to choose, or what direction to take, then I think this is also something that you can do with AI. And this is basically why we have lots of scientific research partners, and also big laboratory chains that provide us data and also insights into their workflows currently, and we provide the knowledge on how actually to use the data to improve the whole process.
so the AI that you're looking to build in kind of the different iterations, it would look at research topics about what drug combination or different types of therapies based on timings, percentage, volumes, that kind of stuff, and based on what they see or what you see from a disease standpoint, it would give you a recommendation of the best possible treatment for that particular thing based on the data that's being fed on the research that you've put into that. Am I on the same page?
Yeah, so
1 million miles
currently
away.
what they developing, the immunotherapy, is basically personalized precision medicine. That is, it's not a drug that you can just go to the pharmacy and buy off the shelf and every patient takes the same. This is really a medication or therapy that's really designed for a particular patient. And this whole process of designing the therapy, or the treatment, is something that needs to be monitored, that needs to be quality assured, and there's a lot of different aspects of information that go into there. And this is basically why, like as I said, we work with partners here together, and that are experts in these domains. And I think together we can build something pretty great here. But it's still disclosed what actually we're doing under the hood here.
Yeah, I'm not surprised, man. I'm not surprised. Honestly, Felix, it's absolutely fascinating, and I really hope you guys nail it. Because I think if you do, it will just be amazing. I mean, everything that you said to me today, I mean, I wish we had another hour to discuss it in more detail so you could school me on everything, but unfortunately we don't. But I guess the final question then I've got for you, Felix, is like, what's the end goal for you guys? Like, I mean, if you were going to paint a picture of, I mean, your expectations of where the business is going to be and what you would consider success, how do you see that playing out? Like, if you could visualize that and then explain that visualization, what would that look like and feel like?
I mean, for me, using this type of technology, it's already success if we can change the life of one single patient. If there's one patient where we had an impact on his treatment, on his recovery from cancer, and I think then it's already success. If we can change the life of one single person, then this is already amazing. But of course, we want to build something that doesn't impact just one person. We want to make it scalable. So I think if we can really build a pipeline here that helps not just one patient, but basically all patients that have these types of diseases, I think this would just be amazing.
Me too, man. And I wish you all the best in achieving all of the goals that you're looking to achieve, man. So honestly, Felix, it's been an absolute pleasure to have you on the podcast, man. And thank you so much for taking the time to give us all a snapshot of you, your background, and obviously what you guys are working on. Again, if anyone's listening right now and they want to reach out to Felix or the guys at Hema.to, please do, because I think it's a use case that needs good people to help solve mentally challenging problems. So yeah, honestly, Felix, thank you so much, man.
Yeah, thank you, Luke. It was a great pleasure to be here.